So next one, 5.16. A compressor is used to compress helium from 120 kilopascals and 300 Kelvin to 750 kilopascals and 450 Kelvin. A heat loss of 18 kilojoules per kilogram is found during the compression process. Neglecting kinetic energy changes, compute the power input required to maintain a mass flow rate of 88 kilograms per minute. So if it's not one thing, it's the other. First, we said we couldn't neglect kinetic energy in the other question, and now we're saying it's actually not adiabatic. There's some heat loss, but now we could at least neglect the kinetic energy. But no matter either way, the first law of thermodynamics is what we need to solve this. So, few things to note. We want to find the power input, which means we're looking for something in kilowatts, but the heat loss we're given is in terms of kilojoules per kilogram. So we need to go from kilojoules per kilogram to kilowatts, and the link to do that is always the mass flow rate, and they're specifying a mass flow rate for us in terms of per minute, but we're going to divide by 60 to get it to kilograms per second. But enough talk, let's do the question. I'm going to open it up there. Okay, so first law of thermodynamics. In this case, there is a Q. Q minus. There's a Q dot. Obviously, this is a compressor where inputting works, so there's minus W dot equals M dot, and they're telling us neglect changes in kinetic energy. So we're just going to have H2 minus H1. We're also neglecting changes in potential energy, which is a fair assumption. So, where was it? Yes, so this is argon gas. Again, we don't have the property tables for that, but like with the last question, we're going to replace H2 minus H1 with Cp for argon delta T. And we are told the delta T. We're told it goes from 300 to 450. Cp we can find from the table. M dot we're told. Q dot we're told in terms of a per unit mass basis. So before we just throw in the number they give us, which is 18 kilojoules per kilogram, we'll have to multiply that by M dot. So Q dot is really equal to M dot little q dot, which is the per unit mass version. So 88 kilograms per minute, which we're going to divide by 60 to get it in terms of per second, times Q dot, which was, minus 18. So by the way, minus means that we're losing heat. It's giving off heat. So let's do this, 88 over 60 times minus 18. And this is giving us negative 26.4 kilowatts of heat loss. So we know Q, it's W is what we're trying to find. So we're not expecting to have anything to substitute for that yet. M dot is just this guy. I'll just calculate it separately. 88 over 60. It's 1.464. So 1.46 kilograms per second. Cp, well, I don't know, but I'm going to go get it from the table. And if you get it from the table on the first page, should find that Cp for, is this helium? Yeah, helium is 5.1926 kilojoules per kilogram Kelvin. Okay, that's Cp delta T. Well, we're told in the question that T2 is 450, T1 is 300. So we're all good to go to plug everything in. So Q dot is by convention negative because it's a loss of heat. If it were a gain in heat, or rather, if heat was being transferred to the system, it would be positive. So anyways, it's negative 26.4 kilowatts minus W. Okay, we're going to figure out what that is. Equals M dot, which is 1.46 kilograms per second, times Cp, 5.1926, that's coming straight from the table, times T2, which we're told in the question is 450, minus T1, which we're told in the question is 300. And if we calculate all this out, we should be getting a value for W of negative 1168.8 kilowatts. Note this is negative, which is what we expect because this is a compressor. Again, the work of a compressor is always negative because doing it, you're forcing it to do work to you. So that means it's negative by convention anyway.